Welcome to Chemistry Tales. This is Tale 3-2, in which we're going to use the Nernst equation to help us predict the cell potential for a redox titration before we start titrating and after the addition of 10 milliliters of titrant. The first step is to balance the redox reaction between the dichromate iron in its +2 oxidation state to yield chromium +3 and iron in its +3 oxidation state. You must have the stoichiometric coefficients for the reactants and products. From this, we write the Nernst equation for the half-cell reaction of the iron. So that's going to be a reaction quotient or equilibrium constant in which we have the reduced form over the oxidized form. We do this for the initial data point before titration and after the addition of 10 milliliters of the dichromate solution. Initially, we write the Nernst equation. Standard condition cell potential for the iron reaction, 1 mole exchange, and then the reduced form is iron 2 concentration over iron 3 concentration. We need to get the values for those two concentrations. We use the equilibrium constant to get one of these. Solving the standard cell potential for the equilibrium constant value allows us to use that in future calculations. To solve for that, we use the following equation, and now we know that's the ratio of the two iron species concentrations. So we can get at the iron 3 concentration by knowing the iron 2 concentration and the equilibrium constant. We can figure out the iron +2 concentration by knowing the total number of moles we start with divided by the total volume of the solution that we start with. The total moles of the iron comes from the endpoint calculation and knowing the moles of the dichromate ion required to reach the endpoint. From that, you should be able to solve for the cell potential at the initial starting point. Thank you for listening, and if you have any questions, please send me an email. Thank you.